Okay, so I'm just going to be working through two problems. Your numbers might be different. I changed the numbers in my class a little bit, but if you're in my class, then this would be number 5 and number 7. I'm skipping number 6 because I'd like you to figure that out on your own. So number 5 is asking us to complete the square on a general equation. That general equation is ax squared plus bx plus c. So that's what we're going to do. And we worked on this in class, but I'm just going to go over it as well to make sure that we end up with the same thing. This is not something we're going to have to do a lot, but we're trying to develop the quadratic formula and, generalize some things to save ourselves time. So the first thing we're going to do is subtract c. That's probably the easiest step. F of x minus c is equal to ax squared plus bx. Now, in order to complete the square, the coefficient of x squared needs to be 1, but it's not, it's a. So I'm going to have to divide everything by a. Divide by a, divide by a, divide by a. That's going to give me f of x minus c, all divided by a, is equal to x squared plus b over a times x. Now, bx over a is the same thing as b over a times x. Now I need to complete the square. And to complete the square, I take this coefficient of x right here, b over a. I divide it by 2. And then I square it. I need to add it to both sides. Now this is kind of a nasty thing, so I'd like to simplify this first and then add it. So first of all, when you have b over a all over 2, that's the same, dividing by 2 is the same as multiplying by 1/2, right? And multiplying by 1/2, we would just get b over 2a squared. And b over 2a squared is just b over 2a times b over 2a. So that should just give me b times b, which is b squared, over 2a times 2a, which is 4a squared. So basically, I want to be adding b squared over 4a squared to both sides. This is our completing the square step. We're making a perfect square trinomial so that we can then factor it to a binomial squared. So b squared over 4a squared. Now we're going to factor this, and remember that it always factors to x plus whatever this value is, this coefficient of x, divided by 2, all squared. So I'm going to leave this side alone, f of x minus c all over a, plus this value that made the perfect square trinomial on the right-hand side. And this should then be x plus b over a over 2, which is b over 2a, all squared. Again, just as an aside, remember that if you had x squared plus 6x plus 9, then that would be x plus 3 squared, right? Because 3 is 6 divided by 2, and 3 is the square root of 9. So b over 2a is b over a divided by 2, and it's the square root of b squared over 4a squared, as evidenced by our work over here. Okay, next we need to solve for f of x. So we are going to subtract b squared over 4a squared, and that should give me f of x minus c all divided by a is equal to x plus b over 2a all squared minus b squared over 4a squared. Now I'm going to erase some things up here so that I have some space to finish the job. Maybe you're catching up, or maybe you already finished. I'm going to multiply by a. That's going to give me f of x minus c is equal to a times x plus b over 2a all squared plus a times negative b squared over 4a squared. And that is simplifying a times x plus b over 2a all squared minus b squared over 4a, right? I can divide one of these a's out because a divided by a is 1 and get negative b squared over 4a. Cool. Okay, finally, I'm going to add c. And so that should give me the answer that I know that I want. F of x equals a times x plus b over 2a all squared minus b squared over 4a plus c. Okay, now this is actually, not just a bunch of mumbo jumbo. This actually gives us a lot of interesting information. And some of the information it gives us is it gives us the vertex of any quadratic function based on its a, b, and c values. Okay, that's a pretty big deal. And so we can see here that the vertex of any quadratic function is going to occur at negative b over 2a, comma, and then this whole nasty thing, which is negative b squared over 4a plus c. So this might not be that practical, the y value, but this is pretty practical. That's actually the axis of symmetry. X equals negative b over 2a. So that is a good thing to know. That is the axis of symmetry. Anytime we want to find the axis of symmetry, we could just do negative b over 2a. That's wild. So we just found that, and that's cool. All right, so now moving on to maybe even more interesting algebra. This is the answer that we just got. We got f of x, a general quadratic, ax squared plus bx plus c, written in vertex form, is a times x plus b over 2a all squared minus b squared over 4a plus c. So now what we want to do with this is actually solve for the x-intercepts. And to solve for the x-intercepts, we need to plug in 0 for y or f of x. So I'm going to say 0 equals a times x plus b over 2a all squared minus b squared over 4a plus c. And to solve for x, I'm going to undo all of the things that have been done to x. Now, the first thing that was done to x is we added b over 2a to it. The second thing is that we squared it. The third thing is that we multiplied by a. And finally, we subtracted b squared over 4a and added c, which is all, kind of the same thing. So to solve for x, I'm going to undo all those things in the reverse order. And that means first, I'm going to add b squared over 4a and subtract c from both sides, plus b squared over 4a minus c. And that should give me b squared over 4a minus c is equal to a times x plus b over 2a all squared. Now, in the interest of simplifying, I'm going to combine these two things over here, the b squared over 4a and the negative c. And that should be b squared over 4a minus 4ac over 4a. Right? Because 4ac over 4a is the same thing as c. I've just gotten a common denominator of 4a. So that should be equal to a times x plus b over 2a all squared. I think I can move this over here. I don't know. So let's try writing that up here now. We're going to continue simplifying. So we're going to write b squared minus 4ac all over 4a is equal to a times x plus b over 2a all squared. Now I'm going to divide by a, and that gives me b squared minus 4ac all over 4a squared. And that's because when you divide a fraction by a fraction, you can also just multiply the two denominators. And that should equal x plus b over 2a all squared. Now I'm going to take a square root, and I'm just going to flip this thing around just because it's a little bit easier to write that way. So I'm going to do this little number, and that should give me, whoopsie daisy, that should give me the absolute value of x plus b over 2a is equal to the square root of b squared minus 4ac all over 4a squared. Okay. Now I'll go to a new page here to finish this off. I have now x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. And that's because I had the absolute value. So now it needs to be equal to the positive or the negative, because the absolute value of a positive is positive and the absolute value of a negative is also positive. And finally, I'm going to subtract b over 2a, and I should have x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 4a squared. Now this probably, if you know the quadratic formula, it's starting to look a little bit similar, a little bit familiar, but it's not all the way there. So what I can notice is that the square root of 4a squared is in fact 2a. So that means this denominator down here is actually 2a. So I can write x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, because that's the square root of 4a squared. And now I have the same denominator, which is magical. And I can write x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you have the quadratic formula. Quad formula. Which will solve any quadratic equation as long as you can find the a, the b, and the c values. So that's magical. Now that you've derived the whole thing, you own it and you can use it to solve any equation that you want. So I hope that was helpful. See you soon.